Hey there, welcome to this masterclass. Before we write a single line of code today, I want you to imagine this scenario. It's 3 am, your phone rings, your CISO is on the line. Someone just pushed a commit to GitHub with an Azure OpenAI API key embedded in a .env file. The repository was public for 4 hours before anyone noticed. In those 4 hours, the key was scraped by bots and used to rack up $47,000 in OpenAI charges. Not just this, because the application relied entirely on password based access, the blast radius wasn't limited to OpenAI. The same .env file also exposed credentials for the Azure storage account, Key Vault, and production database, all protected using passwords or static secrets. Attackers didn't just burn tokens, they exfiltrated data, enumerated blobs, read secrets, and touched production database. But the real cost, the reputational damage, the customer data was accessed, and this calls for an emergency security audit. And the total bill? More than 50 million USD. And in case you are wondering, let me tell you, this isn't fiction. Variants of this story happen every month. And here is the terrifying part. A huge percentage of generative AI projects still begin with developers copy pasting API keys into environment files. Today, we are building something different. A sample RAG agent that runs on Azure Kubernetes Service and accesses both private data and AI model without a single password, API key, or connection string in the code. By the end of this session, you will understand why workload identity is not just a nice to have, but the only acceptable way to deploy modern generative AI workloads. Okay, now since the context is set, let me show you how most generative AI applications are built today so that you understand the problem statement slightly better. So for this demonstration, I built this simple RAG agent using LangChain. Alright. So as usual, for pulling some blob from the storage account, it relies upon this environment variable, and then for connecting to OpenAI and getting the response, it relies on certain other environment variables. I've just tried to mimic a regular agent. Obviously there will be more environment variables in a real world application. And then it is a simple application code. I have built this Ask API inside Swagger. I have used Fast API so that we can query and get response in some UI, right? Swagger UI. So very straightforward. What it does is basically, connect to Azure OpenAI, creates this LLM object, then it invokes this function to download the blob from the storage account with this particular name, and then it sends the data to LLM, retrieves the response and displays it. It's very simple RAG agent we have created. Okay, it is time for a quick demo. So I have got the Docker file as well as the Docker Compose. So for us, all it takes is to build and run the application. So Docker Compose up, and while doing, and also build the application. You need to have Docker desktop running in your system in order to do this. Okay, my application is being built. Okay, application is up. Let's see. Okay, this is our application. Now I'll ask a simple question to this. So let me try it out, enter the question here. It is all provided to you in your repository as well. Okay, so if you want, you can try it yourself. Execute it. And as you can see, here is very specific information that is coming from the knowledge base that you have provided, right? And where is this company's knowledge you have stored? It is kept inside this particular storage account, then documents, docs container, and inside this we have got this knowledge.txt blob inside which the particular knowledge is kept. So the response which is coming over here is because we have specified this particular pricing inside the knowledge base, right? So what has happened under the hood? Let's see in the logs. I have written very detailed logs. So it received this question. It initialized the Azure OpenAI configuration, etc. Then it downloaded the blob. Which blob? With the one we just saw, the knowledge base, looking at which it should respond. And then while sending the prompt to LLM, it actually added the entire knowledge base along with the question that we just asked. And that is why LLM was able to give a very precise answer. And that's how this request was completed. This is arguably the simplest RAG agent in the world. But this works for our example, isn't it? Even if you are not getting what is there in this Python code, please do not worry at all. The problem is here. What this code is expecting is something should provide these environment variables to it. How typically we do is create an environment variable file like this. So all these secrets are there inside this, and these environment variables needs to be given to the application in order to function correctly. Yes, these environment variable look harmless. They are just environment variables. But let's trace the life cycle of these secrets. Day 1, developer creates the Azure OpenAI resources, copies the key from the portal, paste it into .env file. Day 30, .env file accidentally gets committed to GitHub because someone forgot to update .gitignore file. Day 45, the key gets rotated for compliance. Now you have to update in 5 different places: dev environment, staging, production, CI/CD pipeline, and the developer's local machine. Day 90, a developer leaves the project or maybe the company, but they still have the .env file on their laptop. You have no way to revoke their access without breaking production because you cannot rotate key every single time a developer leaves. But here the expectation is that every time a developer leaves, just to keep the environment clean, you should rotate the key and update it at every single place where that key is used. It's difficult, isn't it? This is what I call secret sprawl. Every secret you create becomes a permanent liability, isn't it? If you realize in this system you are trusting that a developer won't accidentally commit this key to GitHub, that someone won't paste it into their Slack, that it won't live forever in the terminal history, and that a former employee won't still have access to this key months later. My god, that is a lot of trust to place in humans. Trust is a great human quality, but it is a terrible security strategy. And that is why these environment variables needs to be addressed more carefully. And this is not it. Let me show you another problem. Look at this connection string. This is a God-made credential. With this string, you can read, write, delete, and destroy an entire storage account. There is no expiration, no scope limited. If this leaks, you don't just have a security incident, you have a business continuity crisis. Do you realize that? As a generative AI application architect, the question we need to answer is how do we build generative AI applications without creating this liability? The answer is Azure Workload Identity. Let me show you how. The fundamental shift we need to make is moving from human trust to machine verification. In the old model, we trusted a secret because a human created it and secured it. In the new model, we use cryptographic proof that a specific workload is who it claims to be. Here is how it works. OIDC issuer. Think of this as a digital notary inside your Kubernetes cluster. Every pod gets a unique token that says I am pod X running in namespace Y on cluster G. Next, managed identity. This is like a service passport. It is an identity in Azure Active Directory. Because it has no password, it is purely cryptographic. Next, federated credential. This is the trust bridge. We tell Azure only accept tokens from this specific Kubernetes service account in this specific namespace on this specific cluster. The beauty of this system is no secrets ever leave Azure. When your pod needs to access OpenAI or storage, it presents its OIDC token. Azure validates it cryptographically and issues a short-lived access token, valid for just 60 minutes. If that token leaks, it expires automatically. No key rotation needed. No emergency 3 a.m. calls. This is the zero trust model, and it is not just secure, it is operationally superior. Let me show you how to build this. In interest of time, I have already created a few resources. So this includes container registry inside this particular resource group. There is Kubernetes cluster, storage account where we will keep our knowledge base, and Foundry project I have created so that we can deploy our LLM models and access it using an endpoint. Now we need to execute certain AGCLI commands. You can do it from Cloud Shell, or you can launch a PowerShell session and install AGCLI over here and do a AG login. Let me show it to you as well. That's it. Let me clear my screen. And we have done AG login. Now we will be running our application on the Kubernetes cluster. But in order to store the container images, we need to keep them somewhere, right? So in our case, we will be keeping them inside container registry. In order to pull down the images from container registry, we need to pass image pull secret. But entire exercise that we are doing here is no secrets at all. So even for this one, we will not go via the secret. I want to make it entirely passwordless. So for this reason, let's execute the command. Please understand what we are doing. We gave our AKS cluster permissions to pull images from ACR or Azure Container Registry without needing to pass Docker credentials. This uses the kubelet managed identity, another form of passwordless authentication. In the old world, you would create an image pull secret with Docker credentials. Those credentials would be stored in Kubernetes secrets. If they leaked or expired, your deployments would fail. Now, the cluster uses its own identity to pull images. No secrets, no credentials. This is consistency. We are eliminating secrets at every layer. Let's wait for this to complete. Next, let's go to our Kubernetes cluster. Need to make certain changes over here. Okay. So go to security configuration. You see, these settings are disabled by default. Enable OIDC, enable workload identity. These are not done because we were not making use of workload identity till now. We were not educated enough. I can put it this way, right? Now, since we know this, so let's execute this command. This command does two things. Enable the OIDC issuer, which creates the digital notary I mentioned earlier. And also it activates workload identity support for our cluster. This takes about 2 minutes. So let me resume recording once it is completed. And there we go. The command is executed. So let's go to Azure portal and verify this. Awesome. You can see both OIDC and workload identities are enabled. Indeed, we could have done it directly from the portal, but when we work in enterprise environments, often our portal access is limited. So I have to give the steps that works for you. Issuer URL is important. We will make use of this shortly. But before that, we need an identity to which security roles can be assigned in Azure. So let me go here, paste this command. So this is about creating this identity with this name inside this resource group. Let me hit enter. That's it. And very quickly the identity is created. Let's validate the same. So I'll go to the resource group, refresh it. And as you can see, the managed identity is right here. Now, the next step is the most critical step in this entire setup. You see, there is managed identity to which we will assign different roles, right? We might assign storage account owner role, key vault administrator, and so on. Those permissions are with this managed identity, but till now we have not made anything so that Kubernetes can actually make use of those role assignments. And for solving exactly this problem, what we are going to do is create federated credential. Let me show you how. So let me go to PowerShell again, clear my screen. Now, in order to create federated credential, we will need this issuer URL. It is very easy to directly copy paste this static text and use it, and it works as well. But from one Kubernetes cluster to another Kubernetes cluster, this will change. So it is not good way to use the static text. Instead, we should dynamically fetch the issuer URL, and for this reason, let's do this. I'll create a variable called AKS OIDC issuer, and this will go to my cluster and dynamically fetch it. So let's see what it has fetched. It is this URL which works for us, right? Next, what we should do is create the federated credential using this OIDC URL, right? So this is the name of secret, then this is resource group, identity name, and we must specify the OIDC issuer URL that we just fetched dynamically, right? This is already done. I demand your special attention to this particular string. Look at the subject field, system, service account, default, and then AI agent SA. This is saying Azure only trusts this identity when it is presented by a Kubernetes service account named AI agent SA in the default namespace of your Kubernetes cluster. This is important, isn't it? Because you assigning high level administrator permissions to this identity doesn't mean every workload will start using it. If that was the case, it would have been a huge security issue, if you realize. Good. Let's go inside the managed identity and see if the federated credential is actually created. So I'll go here, and there we are. Yes, the credential is actually created, right? This is the issuer URL of my Kubernetes cluster, and this is the subject identifier that we just discussed, right? Very good. Now let's take a look at the role assignments that we have added to the managed identity. And as it says, there is no role assignment right now. This means we have an identity, but it is powerless. It doesn't have access to any other Azure resources whatsoever. This is intentional. In the zero trust model, nothing has access by default. We are going to use RBAC, role based access control, to give our agent exactly the minimum permission it needs. No more, no less. Now you have to go through the code and understand what permissions are actually required by the application. To put it very simply, we need read access on the storage account, and then we also need the access to the deployment running in our Foundry project. Let's work towards providing these essential role assignments to our identity and hence to our application. First of all, we will need the client ID of our managed identity. So that I can fetch using this. Let me print it for you. So it is nothing but this particular value. And then what we are doing is assigning storage blob data reader to our client ID. Oh my god, I'm sorry. This scope is wrong. So we need to fix this one. Go to the storage account and click on this JSON view. Click this resource ID and add it here. Okay, this is good. Go back to the PowerShell again and execute this command. And this way we have given storage blob data reader permission on this particular storage account to our managed identity. Is it really done? No need to guess. We can actually check it. So I'll go to managed identity, go to the Azure role assignments, and that's it. As you can see, we have given the necessary permission to this particular managed identity. I want you to appreciate this fact that we have given storage blob data reader permission. Means even if someone somehow gets access to this particular identity and start using in their application, they'll not be able to do anything beyond reading the data. They'll not be able to change anything. They'll not be able to delete anything. This is the beauty of principle of least privileges, and you clearly get it now. I'm happy for you. We need to assign another permission to this, which is access to our Foundry project. So let's work towards that also. We'll go to Foundry, JSON view, and I need this. Let me go to PowerShell and execute this command. Notice this time the scope is resource ID of the Foundry project, and the role that we are assigning is Cognitive Services OpenAI user. Let's hit enter. There we go. It is completed. So I have every right to validate the same in managed identity. Azure role assignments. The required role assignment is completed successfully. Cognitive Services OpenAI user. This role lets you send prompts and get completions. It does not let you view billing, delete models, change rate limits, access other customers' data, and so on. If someone steals this identity's token, they can ask GPT questions. They cannot rack up 50,000 billing in charges by spinning up new deployments. This is what I call blast radius engineering. We assume breach will limit damage. Let's see this in action. We've spent good enough time on the Azure setup. It's time to look at the code and understand the changes that are required in order to use managed identity. So we've already seen the code that is written in the old style of directly using the environment variables. Now we need to work towards incorporating managed identity. But should we completely drop these environment variables? I would say not immediately, because managed identity will work within Azure. Means developers working in their own local machines, they'll not be able to take the benefit of the managed identity. This will work only when it is deployed to Kubernetes cluster. So we should write the code that supports both environment variables and the managed identity. That is the way forward. Immediate next question you will have is how to govern this. How do we make sure that developers actually not use these connection strings and you start using the managed identity when it is deployed, right? That's a valid question, but I would like to draw your attention to this very simple option. Well, the solution is very straightforward. What we can do is have this parameter use managed identity, and in local developers can overwrite it to false, and they'll be able to use these connection strings, endpoints, keys, etc. But when it is deployed to the Kubernetes cluster, you make sure that it is turned to true. Obviously you would be using some CI/CD pipeline. There you will make sure that use of managed identity is always true. So, and that's how you will enforce the managed identities are enabled whenever the code is deployed. I hope you get the point. I have already written this code that can work both using managed identity and with passwords. Okay, so it just relies upon this particular variable. If it is false, it will seek these endpoint and keys. If it is true, it will work using managed identity. So very straightforward. We have created conditions like this. Now in order to use managed identity, look at this. We have to import this additional library. Default Azure credential is the Swiss Army knife of Azure authentication. Here is what makes it brilliant. When I run this on my laptop, it uses my personal Azure login. When this runs in Azure Kubernetes, it automatically detects workload identity and uses the pod's identity. When you deploy this to Azure Functions, it uses the functions managed identity. One line of code works everywhere. No if statements, no environment detection logic. Now look at how we authenticate to OpenAI. Notice what is missing. No API key parameter. Instead, we pass a token provider, a function that fetches fresh tokens on demand. Every time LangChain calls OpenAI, it calls this function. The function goes to Azure AD and says, hey, I am this pod. Here is my OIDC token as proof. Azure responds with a fresh access token valid for 60 minutes. Now look at the blob storage code. Same pattern, no connection string, just the URL and a credential. This is identity aware code. It is not just secure, it is simpler. No key rotation logic, no secret management boilerplate, just business logic. Let's deploy it to our Kubernetes cluster and see the magic with our own two eyes. So I'll walk you through the AKS deployment YAML that I've created. First of all, the client ID. So this client ID has to be the one for the managed identity that we just created. I have just updated the old useless value and this is the latest client identity. This is the correct client ID that we have just created. So this is the service account that we are creating. It is the same name with which we created the federated credential. So this is the service account that we are going to use to map the permissions. Notice it is inside the same default namespace and same AI agent SA name that we described in the federated credential as well. You change the name, entire setup will fail. Yes, as well as this client ID. This links our Kubernetes service account to our Azure managed identity. This is the glue. If you give the wrong client identity, your application will never get the correct permission and you'll keep on wondering and you will simply waste a lot of time. So make sure you double check this. Yes. Now look at the pod specifications. You must add this label to your pod in order to make it work with workload identities. As well as you have to describe the service account name that you want to use to give identity to your pod. And that's it. This is all you need to do differently in order to use the Azure workload identity, right? Not a huge change, I believe. In case you are wondering, there are still environment variables. Yes, there are environment variables, but you can afford to tell everyone that these are my environment variables, right? This is storage account. There's no password, there's no connection string inside it. This is endpoint, not the OpenAI key. Using this, an attacker will not be able to do anything. And this is your deployment name. These are not secrets, these are just configuration. This YAML file can be committed to GitHub, it can be shared in Slack. It is a public information. I don't shy away from informing everyone else that I'm using OpenAI, right? I don't have any problem in telling that this is my storage account URL. So it's okay. I can commit it to my repository. Yeah, why not? Next, I want you to notice this. What is the image described in the deployment? It is this one, which is the ACR I have deployed in my resource group, correct? Ideally, when we are pulling images from our ACR, we need to define image pull secret as well, because we have integrated our Azure Container Registry and Azure Kubernetes services in the beginning itself. So we can do this directly. But if you have not executed that step in the beginning, you will not be able to do it without image pull secret. But hey, another important thing, did we even push this particular tag to our ACR? The answer is no, we have not yet done that, right? So let's do it first. Enough talking, doing nothing. Not good. So I'll do it in terminal over here itself. So first of all, create this tag locally. Okay, this is done very fast. Now we will create the tag so that we can actually push it to our ACR, right? So what I'm doing is create this particular tag in this style so that it can be pushed to this particular ACR. Let me hit enter. Now I'll see the Docker images. V10, with V10 it is one, and this is the one we will actually push to our ACR. Now we are all set to push this tag to our Azure Container Registry. But before we do that, we must log in. So let me execute this command. And yes, login is succeeded. So using Docker login, I have connected using these secrets, right? Here is my registry secret. This is the login server. This is the username, right? So using these details, we can even connect using Docker command. This might be a new thing for some because we otherwise think we can use only AZACR login, but that's not the case. Okay, good. It's time to push the tag. So I'll say Docker push this particular tag. Okay, copy, paste, hit enter. Good. The V10 tag is pushed successfully. I'll still go ahead and verify it. So go to the repositories, passwordless AI ops, and there we go. V10 tag is right here. How cool is that? With this tag being available in our ACR, all we are left to do is deploy our application on Kubernetes cluster and see the things happening right in front of our eyes. So I'll go to Kubernetes service. I can very well do it from my local PowerShell as well, but I want to show you different ways of doing the same things. I'll just launch Cloud Shell. Let me see if there is any other change here. Nothing. Okay. kubectl get pu. There's nothing inside my default namespace, right? Minus, I'll say default get all. There's nothing except this default resource. I'll just upload this particular file and see if that works. So I'll just upload it like this. ls, yes, the file is here. Let me apply this kubectl apply -f aks deployment.yaml. Enter. Okay, so pod is here, service is created, then deployment is also created, and the replica set. This is fine. Let me show you the service account as well. So, and you need not to define the default get SA. Here is the SA created. Let me show you. -o YAML. And as we can validate, the service account is created correctly. I can very well go ahead and see if the application is usable using this external IP. I'll go here, hit enter. Yep, this is Swagger endpoint, but all I need to do is add /docs to it to see the Swagger page. And yes, ask API endpoint is over here. Let's try it out. I'll try using a question that is valid question to ask this one. This is the question I'll ask. Can I book a meeting to discuss using my $2,500 learning budget? Okay, let's execute. And look at this. No, Focus Wednesdays prohibits any meeting or calls between 8 to 17. And what do you think from where this response is coming? Well, indeed it is coming from the knowledge that we have given to it. Look at this. Focus Wednesdays, no meeting calls allowed between 8 and 17. This is added in the knowledge, and that is why LLM responded with this information. So clearly it is reading our knowledge and accordingly giving us answer, right? I also added this LangChain and managed identity. So in local when we were running, right, it was clearly saying it is API key using which all authentications were done. But when we have deployed it to Kubernetes cluster, there we have done it using managed identity. This is nothing to bother as such. It's just a string I have added. Okay. So this is just the auth method which we have added, and see, so don't get overwhelmed looking at this auth method. It is just a string that I am printing. Okay. How cool is that? Let me show you the logs as well, so that you are fully satisfied that indeed managed identity is being used. Look at this. It's clearly using managed identity to access storage. It's indeed working, isn't it? But I would say let's try one more time in follow mode. So logs will be followed, right, as they change. I'm here and I have to try it from this particular endpoint, right? Okay, this is my Kubernetes endpoint. I'll execute it and let's see here what is going on. So it required a new token. This is the request and see what it was doing. So it downloaded the knowledge.txt file from the blob storage account, then and all this, and for this we never provided any connection string to our pod, right? So it definitely used the managed identity And then it went on and connected with the LLM. It read the knowledge, completed the prompt, sent it to Azure OpenAI, received the response, and hence the request was completed successfully. Everything it did without having to use any password. That is the beauty of using workload identity here. How cool is that? And this is how it was able to give very precise response to our query. Well, I'm very sure it is working in exact this manner, but you see, you have every right to question me and basically not believe what I'm saying. I agree with you. You have every right to question this, and that is why let me prove my point. Let's go to the storage account. I'll go to the IAM. I'm not going to break anything from our setup, right? I'm going to the storage account that I'm sure we must use inside our application in order to make it work, right? We'll go to the role assignments. There is some managed identity to which we had assigned, right? What was that? This one. So I'll go here, search for what are the roles assigned to this. And to this, we had assigned storage blob data reader. Okay, it's time to remove it. Delete this role assignment. Very nice. Now, without we have not broken anything from our setup, right? It's exactly the same. I can very well execute it one more time and should expect a response, right? Let's see if it happens. And no, this time it started throwing internal server error. Why would it do that? Because the logs can clearly say this. This request is not authorized to perform this operation using this permission. And with this, you have no right to caution that managed identity was not the reason behind this setup working correctly, isn't it? Hence proved workload identity has done all the wonders, right? Before we wrap up, let me give you the production readiness checklist for secretless generative AI applications. Please go through this. I am attaching it in the repository as well. You can download it. You can read it from there as well. All right, very well done. I'm sure this masterclass was indeed an eye opener for some of you. I'm sure we learned a lot in this masterclass together. Let me zoom out for a moment. This isn't just about securing one generative AI application. This is about changing how we build cloud native systems. In 2026, every company is becoming an AI company. You are not building one generative AI app, you are building 50. You are integrating LLMs into every workflow, customer support, document processing, code generation, data analysis, and so on. If each of those applications has 5 secrets, maybe OpenAI key, storage connection string, database passwords, etc., you now have 250 secrets to rotate, secure, and audit. That's a lot of work, isn't it? With workload identity, that number goes to 0. Not 10, not 5, 0. This is what enables GitOps at scale. Your entire infrastructure, including generative AI applications, can be described in Git. No secrets in a repos, no secrets in CI/CD variables, just identity references. This is what enables zero downtime key rotation. When you need to rotate credentials, you revoke the role assignments, then re-add it. The application doesn't restart and users don't notice as well. This is the competitive advantage for 2026. Companies that embrace workload identity will ship generative AI features faster because they are not fighting secret sprawl. Companies that don't, they are one leaked API key away from a 50 million incident. Security is not a bolt-on feature, it is the foundation. Workload identity isn't just about preventing leaks, it is about building systems that are secure by design. Thank you for joining the masterclass. Let's build passwordless. Thank you.